Okay, welcome everybody. Thank you for joining us this afternoon or this morning, depending on where you are in Australia. My name is Matt Hunter and I'm the Product Manager for Innovation at Contact Malta Australia. With me today, I have Wojciech, or Woj as we prefer to call him. For those of you who want to contact him directly, he's happy with Woj. He's our 3D applications engineer. Today, we want to have a bit of a chat to you about additive strategy for manufacturing or for business. So really, how to look for applications to use 3D printing to make your business more innovative, more cost-effective, less reliant on suppliers. So we've got about a 35, 40-minute presentation to run through. Please feel free to pop questions in the Q&A. We are recording the session as well if you don't have time to run through the whole session today with us. So without further ado, I will hand over to Woj. You'll probably hear from me a little bit during the course of the presentation also. Yes, additive printing strategies for 2021. Woj.
Thanks, Matt. Hi, everyone. And I'll be talking to you a little bit about, the ways that we can integrate additive manufacturing technology into your business this year for various reasons. So just as a quick intro, what we do is additive manufacturing. We refer to that rather than 3D printing. 3D printing itself is actually quite an old technology. A lot of people are still very unfamiliar with it, but it's been around since the 80s. It was just a prototyping technology, and the way it worked is you would generate a three-dimensional CAD model of whatever object you wanted to make, and that object is then sliced using software into different layers. Those layers are then reproduced physically using the machine of your choice. So they could be powder machines, resin machines with lasers, plastic deposition machines, even paper cutting machines that will then glue those layers together. There's all different kinds. It's been around for a while. It's a very tried and proven technology. There's always new developments in it. And there's multiple processes available. Every business is going to need a different kind if it needs it at all. And there's a plethora of choice that can be taken from. And the other important thing is there's also a very big choice of materials, which we'll be talking about as well as we go along. So as I said, we refer to this stuff more than as additive manufacturing rather than 3D printing, because where we're coming from, it's much more of a manufacturing technology. It's very valid for manufacturing parts. That wasn't the case up until a few years ago, but the improvements in material technology, material science, the actual quality of the machines, the quality of the parts that you get have been staggering. It's very much an exponential curve where the last 25 or so years have been steeped in the world of prototyping and hobbyist printing. And in the last few years, we've really been able to use this stuff to do structural components. If anyone's familiar with medical implants, such as titanium, 3D printed titanium and metals, bits for automotive, aerospace and so forth are now being legitimately printed. They are rated and legitimate structural parts. They're as well as very high-end plastics, nylons, things like that. And there's obviously a lot of advantages. It competes very much with subtractive manufacturing and gives you advantages that subtractive manufacturing can't achieve. So you can see in the images, obviously, we're talking very much more about the industrial grade of printing rather than the little hobbyist plastic printers. But at the same time, the solutions that we offer aren't always super expensive and super scary. And we'll talk a little bit about that. So what's the point of this presentation? The point is to really just have a battle plan and a strategy on how these technologies can be integrated into a business to make it better, to save costs and give you a whole series of other advantages. Obviously, not every business is going to need it. Sometimes businesses that are interested in it, after reviewing it, realize they don't need it at all and they just got excited for no reason. Whereas other times, and very often, we find that by integrating additive technology into a business offers very genuine advantages, and it lets you harness that technology in numerous different ways. So this the next half an hour is really going to open your eyes, hopefully, to some of the strategies in which you can use to do that. So firstly, I'm just taking a step back. Australia, we're known as a country that's relatively innovative. We can always come up with a lot from very little, primarily because we're obviously geographically removed from the rest of the world. But the truth is that we're about 5 years behind the European and the US markets as far as adopting 3D and additive technology into our I guess product manufacture goes. So you can see at the bottom there, there's a bit of a curve. Where we're very much in the late majority and the laggards. All in all, there are still obviously a lot of places and a lot of businesses of all different sizes that jump in early and face those battles of having technology early. And generally, I think I haven't heard of any that have fallen over after doing that. They all do end up coming up tops, but unfortunately, that's not the majority of the people in the country. And that's obviously there's cost reasons for that and other reasons as well that we'll look into.
Well, we chatted about that more. I kind of wonder, what's driven that kind of late start for Australia. And I look at it, and I guess we went through a period of offshoring a lot of manufacturing, and that was to Europe or the US or Asia, and they've had a need to really kind of try and adopt this technology a lot faster than Australia. And now that that's kind of turned on its head, and I guess with the risk of saying COVID has forced us to relook at manufacturing in Australia, and we should be manufacturing in Australia. It's now becoming more relevant to look at these types of technologies, and it's never too late, right? It's never too late to be in the late majority and still take advantage of this type of technology.
Well, absolutely. I mean, of course it's never too late. And I guess to answer that point, Matt, as well, I think the other main reason that we are a little bit slower is that our market is just smaller than someone like the US. Like, we're 1/10 of the US. So it's obviously a little bit harder for people to take that risk, but the ones that do usually end up pretty good. Now, do any of these sound familiar? These are pretty funny, I guess, but they are very much taken from life. I do a lot of consulting with clientele, and these are the excuses we usually hear about as to why people who would benefit from this technology don't have it. And the one that says I've got to clear it with a wife, that's based on facts. So they're all very true. But we're gonna, like I said, it's very humorous, but all of these can be very realistically answered and addressed and actually solved if you just look into things and examine things in a little bit more detail. I think, all in all, it's best encapsulated by that little cartoon that says we're too busy for improvements. That's always the case. People, businesses are always working. This stuff does take a little bit of time to implement for various reasons. And I think it's that lack of commitment to improvement or allocating time to improvement that's really the big hurdle for a lot of places where it doesn't have to be. So, what does this stuff actually do? It's, to sum it up best, it can really, to focus on smaller businesses to begin with, and we will get to larger businesses as well because this applies to everybody. But it really does empower manufacturers, for starters, small guys, with a tool set that lets them compete with people that have a lot more money and a lot more size. So small businesses can produce products that are high quality, they can punch above their weight. And it's not just about printing the end product. It's also about implementing, processes in the way to making that product that reduces things like tooling costs, streamlines their design process. The ability, for instance, if you're going to invest in a $50,000 injection molding tool, the ability to print that product accurately, including all the shrinkages and all the tolerances, and pre-visualize it before you make the tool. A printer that does that is readily available. It's not very expensive in the greater scheme of things. And having one of those could save you literally millions of dollars in tool changes and cutting tools to begin with, if you can pre-visualize it and find any problems with it earlier. So technology that lets you do that isn't all that expensive. It's very good and it's very reliable. So I guess the other thing is if you are a smaller business, you're usually down the bottom of the chain for bigger businesses that provide services for you, like molding, and that can lead to a loss of control. You obviously have your own customers, and if you're in the middle and you're not in control of what you're outputting, then your customers suffer. You don't get a very good name. That can totally kill your business, And you don't generally have means to, stick a big injection molding machine in your warehouse, but you can have the means to put a printer in there that will help get the results that you need. So it's like this. For example, in this particular case, we're not printing the actual bottle. That's not the printed product. The product has to be molded because of the material properties that you need for the bottle. But if you are doing something where you only need a smaller volume of bottles, you might not need to make 1.5 million of them. And a bottle is just an example. It could be anything. If you only need a small run, then the cost of cutting that tool on the right is probably barely more than the cost of the printer itself. And that printer can give you, the tools that come off that printer will have a shorter run, but you may only need a shorter run. And it'll also give you the ability to develop that product, pre-visualize that product, address any design changes, and the materials coming off it are good enough to do a whole plethora of plastic products out of nylon and things like continuous carbon fiber, Kevlar, and so forth. So we have a lot of businesses that are harnessing that at the moment to generate their parts or address steps like making injection molding inserts to get them to the final product. And the quality, like I said, the quality of the product that you get at the end is the same for both of these, except in one case, you don't have to invest a huge amount of money to get there. In another case, the end product could be the product that you actually print. So this is a really good example where there's a system that prints end-use rubber. It's a 65A grade rubber for printing things like motorbike handles, and we'll get to some examples of that in a minute. The machine on the right is obviously worth 10 times what the printer on the left is worth, and you have to cut a tool every time you want a different design to put in that machine. Now, if you're making 1.5 million identical grips for your bike, different story. But if you're making them custom for lower volumes for certain customers and you only need 2 or 4 per customer, you can easily modify that design for every customer. You can put their logo on it, you can change the pattern on it, and it'll give you the exact kind of rubber. So this is my point from earlier where I was saying that material advancements have now allowed us to do that. Now, 6 months ago, this material wasn't available, and the only rubber available on this printer was a prototype grade rubber that you couldn't use as an end-use product because it would disintegrate. Now, since then, the material has been released that is an actual end-use rubber. So if you're doing grommets, seals, custom seals for products, anything like that, you could be an injection molding company that makes hard plastic shells that need a little seal in between them, and you want to just make a number of them to fit that particular product, and this solves your problem. So the other thing it also allows you to do as a small business and even a big business, you can have a digital inventory, a digital library of your parts that you share with people internationally or with customers, and you don't need to warehouse any of that. So it really just eliminates a lot of cost and gives you a whole bunch of design flexibility and design freedom that you may not have. And obviously speed as well. You don't have to cut a tool for a week. You can get these things printing overnight just with the design file, which is great. So we'll go through a few examples of smaller businesses first that have really managed to harness the power of additive technology locally. For instance, the first, all of these guys were very kind to let us use their information. They're all Australian businesses, apart from a couple in the end. Australian Vehicle Conversions, great little business. What these guys do is they convert American cars to Australian cars. They just flip over everything in the car from left to right-hand side. Very small, just based on the Central Coast, and they compete with guys who are much bigger than they are. The product they make is very, very high value. They only do a few cars per year, but all the cars are obviously very high value to the customer. They need structural strength for their parts. They're not just aesthetic pieces. They actually do things like the whole dashboard conversion. They flip everything over. Everything's remodeled. And they need things like lights out machining. The machines that they use to print the parts that they need have to run non-stop because of the volume of cars that they do. And the parts have to integrate with the post-processes they have, like they have to be able to put vinyl on the parts, polyurethane them, spray them, glue them, and so forth. They've invested into just a few small machines to begin with, with very, very little experience originally in CAD and 3D. The people that run it have much more experience in mechanical engineering. They're not so much computer people. Within a matter of weeks, they were right across what they had to do to get this stuff running. It was a very easy learning curve. They adopted that technology very quickly, and they've since expanded a number of times, and they constantly now need new machines, and they can get by using very small, cost-effective machines to run this business, which is a wonderful story. Very similar, custom motorbikes. There's a company called Motor Galore who make motorbike customs. Once again, very high value. These some of these bikes go in the hundreds of thousands of dollars for collectors. They need to make custom parts. So the rubber grips that you saw in the previous picture is from this company. Once again, they run a series of small machines. They only started off with one little baby plastic machine, and they've worked their way up to a few more to meet the volumes that they have. So at the moment, I think they're running 4, including one of the rubber units. It's an international client base, so they provide these products for people as far as the US. We have people in America buying rubber grips from Australia, which are printed. Go figure, but it does exist. And if you're in that market space and you're in things like motorcycle clubs that are international, then all of a sudden people will ship this stuff from Australia to America and buy it off you. So it's opened up the business quite broadly for them. And there's a constant growing need for further expansion, because the more people that get these parts, the more they want to tinker with it, the more they want to develop their own designs, and all of a sudden the business grows. And once again, another business that started with very little to no experience in any kind of CAD work or 3D design, that has all of a sudden managed to uptake it very quickly, adopt it, learn the software, learn the actual servicing of the machines, everything like that. And it's much more user-friendly than running a 5-axis CNC machine. Let's put it that way. So you can see over here, these are the rubber handles. Just got a little quick video, just so you know I'm not making it up. Check this out. Here we go. So you can see that's legitimate rubber. So that's your little pegs over there. That's all come off that machine. So the machine has a relatively small print bed, but it's very tall. So things like handles, cylinders, stuff like that. Little grommets and seals fits on there beautifully. You can see the finish is great. But the most importantly, it's always about the material property. You don't want this stuff disintegrating after being on your bike for a week. So this is an extremely good end-use rubber. We've been waiting for something like this for years. But there it is. You can see very flexible, very tough, very cool stuff, and very cost-effective as well. Each of these parts is a couple of dollars. So they're not an expensive product to make. Another local company, Rotocaster, they're up on the Central Coast. Once again, these guys have an international footprint, very, very high quality product used for industrial automation. They're like little multi-directional wheels. They make these things by the million and install them in things like conveyor belts and transport. They bought just one little prototyping printer a little while ago, and that's allowed them to design and develop products that are structural. So you can see over here, that's actually a little widget for the blind. So they are now making canes for the blind, because apparently the little nylon ball that goes on the end of a cane wears out very quickly. And the wheels, if you can see what they've done there, they go in all directions. They last much longer. So they were able, these are the actual end-use product. I don't think they'll ever go off and injection mold these. They'll just print them. Structurally wise, it holds up and it allows them to expand into a whole new market, plus do something that's actually, pretty good for everybody. And diversify and design other projects that otherwise they wouldn't be able to do, because the previous printer they had wasn't really able to print structural nylon, whereas this one does, and they can sell this product. It's legitimate. It's an end-use case. So just in case you think I'm making this one up, I don't know why that's black and white, but this is a little load cell test. Watch this. This is the same printer that Rotocaster has. So you can see it's 21,000 pounds of force pulling that apart. That's printed with continuous carbon fiber on the inside. Here we go. Boom, there it goes. So point of that, you can see the little printer that came off is on the right. It's a very cost-effective printer for just about any business. There are people now, there are drone manufacturers who are making parts of this thing. There are people who make surfboards and watercraft that are making fins. Out of this, they sell them as an end-use product because the finish is incredibly good. It looks like injection molded glass-filled nylon. And most importantly, you can use a whole series of different continuous fibers for reinforcement on the inside. So things like Kevlar, for things that need memory, like cycle testing, all that sort of stuff. It's very cheap material. It's incredibly strong. They're real parts. They can be customized. And the beauty is it's all a digital inventory. So you can make things on demand. And I'm rattling a whole bunch of these things off, but if you're keeping track, you can slowly start to understand where things like cost, digital inventory, design freedom start to make sense, where businesses struggle to source parts and have expensive design changes. Whereas if you're able to control that yourself, you are now immediately empowered to do a lot more than you could before, and it does actually save you money. Over here, another great local business called Orthotics. This is a great example. This is a company that makes orthotic devices, things like splints and medical support devices. When we spoke to them about them moving over into a digital plaster room, so to speak, they had virtually no idea of 3D printing or even CAD or computer work. Now I applaud these guys because they were absolutely fearless. They put a lot of trust in us that what we were telling them was right. And they made a very large investment into a very big nylon printer. You can see the printer on the right. It was a huge risk for them to take. And this is what I mean. These are the opposite. This is the opposite attitude to what we experience of other places. These guys just said, you know what, we're going to go for it. We think this is a better way. We think this is the future. And we've only really the information we gave them and their own research, they decided to ditch the entire messy sanding, plastering process that they had for making orthotic devices and went fully digital. Now, after I think they've had the machine now for about 2 years, and they've just gone great guns. And because of that initial investment and risk, that's paid off phenomenally, because now that they're in a digital workspace, they can turn over cases a lot quicker. So you've got instances, for instance, where if you're putting a plaster cast on a child, the time that it takes to make the device using plaster or if you're laying up carbon fiber, anything like that takes so long. Sometimes that by the time the device is finished, the child's already grown and you've got to make another one. Whereas in this particular case, you can blast things out overnight and turn over more cases, which leads to more business. And lo and behold, you can expand into other things. They're now doing things like cranial helmets for children for head deformation, which is incredibly high value as well, and relatively small amount of work for what you can make for it. And the other interesting thing to mention about these guys is by adopting that 3D digital strategy, they haven't actually lost any of their traditional skill set. They've just applied that to digital, which has made them twice as powerful, because obviously they're not losing anything, they're just gaining more. So that's my point about taking risk. Now, just a few quick ones. There's a company called Weta Workshop. These are just over the pond, the Kiwis. The reason I bring these guys up is because they do incredibly high value design for film. These are the guys that made Lord of the Rings and The Hobbit and Avatar and all those films. But they run most of the workshop on a whole series of very small DLP and filament printers that we have as well. And they do world-class stuff you'd never guess, but the actual outlay for the manufacturing process and the digital inventory, the way they can control it on ground level has let them build this colossal, super high-value business just off very simple, low-cost printing technology. And it's very clever, and they use it for molding and forming and things like that, as well as end-use parts. Once again, over the pond, our friends Roden Cars, slightly different story. These guys have 3 or 4 very, very expensive printers. We have those as well, nylon and metal, as well as resin, and they use them to make very ultra high value racing cars. And they're just a great example where they don't have a factory of these, they just have one of each. So it's still a very small place in the context of other automotive businesses. But with a very smart strategy, using those more expensive printers, they're able to compete globally with guys like, Ferrari, Maserati, sell these products for very high cost. And now they're in the process of acquiring the biggest titanium printer in the world to do engines, which is going to be phenomenal. But once again, tiny business that just use a smart strategy to get their foot through the door. So speaking of metal, we don't all have to buy a $1.5 million metal printer. There are other options. So you can compete with metal manufacturing if you're in the metal scope, metal business, tool making business, anything that makes metal parts, by using lower cost metal printing. There's all different kinds, but we find people that don't have $1.5 million and do want to get in the game. There are solutions out there for $200,000. This stuff is incredible because it also does things like copper. It's a very stable copper printer. So things like heat sinks, things for welding. It does steel, tool steel, Inconel, and being able to have access to it at a relatively low price gives you design freedom in the metal scope that you didn't have before. And using that technology, you can expand. You can be a large firm and acquire that and just use it to dip your toes in the water and see how it works. So you've got a digital inventory where you can, once again, you can share parts internationally, and they can go into a metal or nylon printer, give you a good quality end use part. And large firms generally do concern themselves with counting the beans on minimizing waste and maximizing output and minimizing downtime on machines and increasing productivity, taking things down from 5% to 3%, because it does make a huge difference. So, if you're warehousing a lot, if you're finding that, say, you have to buy parts in a greater bulk than you need in order to get a discount from the tool maker from overseas. As we all know, China might give you a free tool, but you have to buy 2 million shots from that tool, and you only ever need 300,000. So being able to, say, remove a part of your warehouse that's full of parts you're never going to use or tools you might change, and replacing it with any kind of printer in that footprint will save you a lot of room. It'll also allow you to make parts on demand. If something breaks down, things like automation, for example, if you are running packaging machinery, if you're running any of that kind of stuff, and you've got a part that breaks, sure, you can get that part ordered, but it might take 3 weeks to get. Now, in the meantime, you can usually make a part overnight that'll get you back up and running again. Sometimes the OEM parts that were originally available are not available anymore, or they're way expensive. Why can't you just make your own? Of course you can, and get up and running. So there's a lot of value in having that on hand. And you can see there's once again, the cost of this stuff isn't really that great. Well, speaking of big companies, this is the GM factory. And just what I was saying about wastage, initially these guys were using some obscene amount of subtractive manufactured steel to make their parts. I think it was 500 ton or some ridiculous amount. But they have since a lot of the parts can be printed. And what they've done is, you can see these are obviously, it's a multi-million-dollar facility. But once again, in the greater scheme of things, it's a huge saving in material, huge saving in power, labor, and so forth. So it applies to big companies as much as it does to the little guys. Now, I guess the question that everyone is thinking is, how can we validate? How do we know that we even need any of this stuff? So the way we do it is we kind of tell people to ask themselves the following points, right? And if any of this applies to you, then you're probably in a boat that could use this. First you got to ask yourself, what do we do? What do we actually do? And if the answer involves the words we make something, then there's a good chance that we can integrate, physical manufacturing, physical additive somewhere in the process to make things better. What volumes do you do? If you do things in a million, forget it, for final manufacturing. If you do, but that being said, you might have automation machine that breaks down constantly where you can use these parts. Do you use tool making and tooling? Do you need to pre-visualize that tooling? And do you do a lot of tool changes? What are all the costs involved? Always add the numbers up for all of these things. And if the dollars for a print additive system are considerably less than what you're wasting on fixing things, then there's a good chance you could use it. Materials are, if you're printing things out of, if you're making things out of vanadium, then there's probably not a good chance there's a printer there for you. But if you're doing things out of nylon, there's a good chance that you can definitely save money. How big are your parts? If your parts generally fit in the readily available print beds on the market, there's a good chance you can use them. If they're gigantic components, maybe not so much. You look at the manufacturing processes you have. Do you do a lot of CNC? Why do you do a lot of CNC? Part design. Do you do part development? Do you have a design department? And by part design, I guess I mean things like this. Can you make improvements? Can you take multiple components that you're using that have a lot of fasteners? For instance, you've got things that have internal features that would initially be made out of two halves and a whole series of things to go inside and then be screwed together. You can now make those in one. There's a lot of automotive companies that are saving huge amounts of money. Guys like Airbus, saving huge amounts of money where they're taking all these components, printing them as one piece of nylon instead of making them out of machined aluminium. And you can imagine in the assembly process, the fastener cost, the weight, all of that stuff has become a lot better. Do you have parts that are very big and solid? Can you lightweight them? You can use things that only additive manufacturing can do, like internal latticing, consolidation of components. You have, 8 components that can go into one. Can you consolidate them? You can see on the right's a great example. You've got this big, messy, heavy thing on that's been converted into a simple printed product with internal features that do the same job. And obviously one's 35 pounds, the other one's 3, does the same job. So consider all those things. It's good to review it, because if you can use this, then it will, in the long term, save you money if you can do those calculations. And by looking at those things, you'll find that it's like a ripple effect where, once you start looking at the advantages of additive, it will force you to look into other areas of your business, and you'll find that by bringing a technology like that into the business, all of a sudden, Larry in the warehouse turns out to be a genius once he's given some tools to play with. And it turns out, everybody can chip in, and the machine that you initially were just using for prototyping is all of a sudden making the jigs and fixtures used in the warehouse that you were previously machining because someone thought of doing that. So it really opens up a lot of people's creativity. Lets you reclaim real estate in your business. Like I said, a digital inventory lets you reallocate labor, where previously the guys that were screwing fasteners together on a parts that's now consolidated, they can be used for a different, they can be retrained or put onto a different part of the business that's more valuable. It forces you to upskill, which means, you might need to train up on your CAD, but that's a good thing because it makes you competitive with everybody else. There's nothing worse than seeing businesses dying because they haven't reassessed what they're doing. And I think additive manufacturing is a real rocket that you put into a business because everyone gets excited. It's quite fun. And it does force people to reassess their business because it's expensive and they don't want it sitting there losing money over time, So the businesses that now are benefiting from it that we've, I guess, come across have the following characteristics. So if you fall into any of these, you can definitely use this stuff. Does any of this apply to you? Do you make prototypes in your business? Do you do any assembly? Are you a technical service provider? Do you need like specific tools to access things like power panels, all that sort of stuff? Do you do maintenance on things that may need jigs or positioning of parts, very quickly instead of holding them by hand? Do you need a jig that will hold something in place very precisely? Do you make plastics or metal? And do you hold a lot of inventory? Do you have a warehouse with a lot of tubs and a couple of forklifts running around? Are you remotely located? Things like mine sites, manufacturing businesses that are further out, where sometimes you might actually need to drive for a day to get in to pick up certain part up or have it delivered. Do you make custom goods? Do you put logos on things? Do you have high value, corporate products that need logos, furniture even, any of that stuff? And are you a service provider where you replace a lot of parts? So, you might be in the business of refurbishing naval vessels or ships, cars, automotive. Automotive's a great example where they always need custom OEM parts that don't exist anymore on old cars and motorbikes. If that applies to you, well, guess what? There's a whole heap of businesses just like that now in Australia that have taken on additive and integrated it and are now reaping the rewards. this is one of my personal favorites. It's just an email that one of our sales reps received come 2 weeks into the COVID shutdowns, I think. And it's an absolute classic because once again, China has ceased operation, and we would, after all, like to talk to you about your industrial size 3D printer. That's, once again, good times, but there's a lot of truth in it because a lot of people, aren't prepared. And we're in the business to try to help we want to grow the local industry and help them be prepared for another COVID situation. If your supply chain is broken, even if the supply of the little plastic bits that make the pump that you make for, swimming pools, it could be anything, that you're sourcing from, Taiwan is broken, then you got a problem because you can't do your end use product, right? So you might need to be prepared for that. And
the supply chain issue is a bigger issue again, right? Because there's a couple of things that have been highlighted, during COVID, and one of those is it's pretty easy to break the supply chain, but two, it's kind of forced people to start reassessing how many parts they're going to order, right?
Yeah. So
volumes have gone down. All of a sudden, you're not ordering as much. You're competing with somebody who is ordering more, and you're further down the chain than them, right?
Exactly.
So you're competing with other people that are ordering more because your runs have gone down, and it's impossible to get into the country, right? So you need to take control of that supply chain back. And COVID's just, that probably was already there initially. COVID's just amplified that considerably, and it just means that you've really got to consider taking on products like additive manufacturing.
Well, exactly right. I mean, it is the old, frog in the boiling pot of water. Everyone's kind of swimming around in it, and then only once it starts to boil do they jump. Yeah. And you shouldn't have to be in there to begin with. So, that's exactly right. We do want to avoid that because it's in our interest to if you pretend that all of a sudden Australia is totally locked up for 6 months, what do we do? How do we make our own things? How do we develop anything? Moving on to exactly, everyone, it always comes down to the dollars with this, always. And before, although, some of this stuff is expensive, other stuff isn't, a cost is a cost for a business, no matter how small or big it is. And I guess what we do on our end is we do assess on a very, very deep level all the beans. We do count all the beans on, the cost of the machine, depending on which one is applicable. The actual servicing of that machine. Every machine needs love, every machine needs consumables, spare parts, and we have to look at how often people are going to be running that machine. Some of our customers run the machine 2-3 times a year, and they can run it for a decade. Other ones, like American Vehicle Conversions, that guy runs those machines non-stop. So he'll change things like the wear and tear on consumables is obviously a lot more frequent. So we have to look at all of that before he purchases. We need to make people aware of all those things so they don't think, oh, this printer's gonna just magically do the job and it's not going to cost me anything, and then they have to change a whole bunch of consumables. Things like training. You don't only need training on the machine and the upkeep and how to run it, but also in some of the back end stuff. I mean, do you know how to model for the technology that you're printing with? Modeling for, say, Mark Forged printers, which are nylon printers, is very different to modeling for the rubber printer. And you have to set things up, and you have different criteria you got to meet. Software, we have quite a few people that don't, they use Tinkercad and Google SketchUp and they think they can use that to make very complex engineering assemblies, in the long term. And it's like, no, you got to understand the cost of software. Good software is great, but it's not cheap.
It's so big training just around, I guess, some of the points you made earlier around design thinking principles, right?
Exactly.
Teaching people how to lightweight, teaching people how to consolidate parts and design, those types of things as well.
Exactly. So just understanding the skill set you may need in your business. A lot of old school engineers have a hard time grappling with these things, but if you approach it right, I think everybody's always open to learning new things. And I think that's where we come into it. So, I guess the question we ask always is, does additive technology significantly ease or save costs of any process involved in creating the final product, right? And if it helps you in any of those things, it's a worthwhile investment like any other investment. If you need a stapler in your business to make things quicker, to send your documents out, well, just buy the stapler. And this is exactly the same thing. So we do aim to provide a very accurate return on investment ROI prediction on what's involved. So like I said, every now and again we got one where it's pointless and the business doesn't need it and they're good to go the way they are. But most of the time there is always a way that this thing makes things profitable at the investment cost. So what we were saying before, all of these points, when you kind of put it all in a big pot, it does lead you into self-sufficiency. From the supply chain, you do want to be prepared just in case. No one wants another COVID. I think it's we've got a wonderful industry, but shipping costs. If anyone's been following the Baltic Dry Index, shipping costs have gone up by some like 4 times since COVID started on raw materials. No one's looking at that. So it is now things like building materials from China have gone, the actual shipping cost is incredibly higher. It's just been sitting there in the background, and being able to provide for those kind of industries, from the home soil is a lot better, especially where, you need a smaller volume. No one likes a huge volume of stuff you don't use. All of this stuff, frees you up. It gives you freedom from over-reliance, like Matt was saying, on a bigger business. So you're not the little guy at the end of the chain. And once again, COVID was like a huge magnifying glass for all this, and it happened very quickly. And a lot of businesses didn't survive it as well, which is very unfortunate. So you'll find that I think everybody that was technologically prepared has weathered it. And we obviously want to help more businesses to stay afloat locally, because we're all about Australian made here. And once again, the holy dollar is always a problem. So, the people are very justifiably worried about, the size of investment they might have to put in. Even a small $10,000 machine might be, sound like a lot for a business. There are grants that are available from the government that can be looked into, technical grants for helping modernisation. And usually, even starting off with a small machine or starting off how the technology works technically is very it's a very smart thing to do, because then that very quickly leads to the acquisition of a bigger system, which helps everybody. Because once you have it in your business, you find that Bob up the road wants to make some parts. All of a sudden, he's sending you more than you can handle. He buys his own. You've got your own. You can share resources, share customers, support each other in case something goes down, so forth. And you've got an industry.
You might not qualify for a grant, and some businesses don't, but there are ways of I guess, overcoming that capital acquisition. So, at the moment, there's an instant asset write-off, for instance, that's going around at the moment. People are taking advantage of that. There's also just, purchasing it a different way. Maybe you want to lease or rent it instead of buying it. So, all those things are on the table for people who want to invest in this type of technology.
Exactly. So as our good friend Benjamin Franklin said, by failing to prepare, you are preparing to fail. That is unfortunately very, very true where we're coming from. Well, I don't know about you, Matt, but I'm pumped. So like I said, if you got any questions, I'm happy to answer.
Yeah, a couple of questions coming in.
Right.
So first one, how do I know what type of 3D printer is right for my application? So think about somebody. They've gone to their business, they've walked away from this presentation and gone, I think I could use 3D printing to do that. How do I know what type of 3D printer I would use?
Well, I think you got to look at we mentioned a few of those points before. You have to really look at what you make, what materials you need, what size of the part you need. Structurally, do you need this to be, ultra strong, or do you want ultra fine detail to previous tools or whatever else? So it really is a little bit about, you can do a lot of this assessment yourself. You don't need us to look into it in depth. A lot of it is sort of self-explanatory. We only really come in and look into, the hard costs of this stuff because we've got such a broad portfolio. But I think, just really doing some research into sizes, materials, definitely print quality, because printers that might print strong nylon may not print, ultra fine jewelry detail. I mean, we've got a massive jewelry footprint, and that stuff does 13 micron wax. won't do nylon. So that's the kind of stuff you need.
I guess materials is one way of describing that. That leads you back to technology, but I get, what we're also seeing is material substitution. So for instance, there's somebody who might have been making something in aluminium in the past is now actually making that out of a continuous carbon fiber product.
Yeah.
So they might not be milling aluminium anymore. They might actually be using a plastic to overcome an issue and create a part.
Yeah, exactly.
Next question. Can parts be made watertight?
Yes, absolutely. I mean, there's a number of ways of doing that. So there's different materials available. There's different resins or deposited materials. You can make things watertight, so something like a Mark Forged. We've even got customers that make fuel tanks out of them. So we got our customers that make custom Jeeps, like defense vehicles, where they make fuel tanks that are literally customized to the little car. They fit in a particular kind of volume on that vehicle, and they do it with enough wall thickness. Obviously, it's a nylon, so it does take on water, but with enough wall thickness and internal reinforcement with continuous fiber, it can be made watertight. There are resins of, say, the Figure 4 system. Although the parts are smaller, they're watertight and environmentally stable straight from the printer. Alternatively, things like SLS parts that are very strong, and you can get them quite big. That's our laser fused nylon, laser sintered nylon. You can do quick post-processing on them where you do dip them in just a secondary resin, and that gives it a skin that makes it totally watertight. So there's different ways to skin a cat. Once again, depends what you're making, but the answer is yes.
Yeah, okay, cool. This one probably goes back to the first question a little bit, where the person was asking about how do I know what type of printing, but what can I do if a part is too large for a 3D printer?
Well, yeah, there's a number of ways of doing it. So once again, American vehicle conversions. His original machine was very small, and he makes dashboards. So to get that technology to work for him, because at the time he was just a test and see, was he anyone he could afford at the time, and to test his test if it worked. What we did was we got the whole dashboard and we just cut it up in CAD software, which is probably the first way of doing it. If you can model a part, then you can just chop it up in CAD. So things like SolidWorks, Pro E, all of them will do it. You just slice it and make model features in it that things like dovetails or, just things like jigsaw together. You can then, Loctite and screw them, do what you got to do. So because the Mark Forged print software doesn't actually have the option to slice those parts, and that's what he was using here to do that in CAD, which is very simple. But if you're using a 3D Systems 3D printer, so say using the Figure 4, which is a smaller bed, very high detail, but smaller, that's software, the actual print software gives you a tool set that will cut the part up wherever you want, and it will put in male and female joins or little dovetails and other options like square pegs, round pegs, all that sort of stuff, holes, things like that. It'll auto-generate them for you. You can specify all the parameters, the sizes, the thicknesses. It'll do that as well. So once again, depending on the printer you got and depending on the CAD process you've got, totally possible and very easy. Just depends which process works for you.
Cool. What's the best file type to print?
Generic one is STL. Like every printer will take an STL file, but the problem with an STL file is you can't edit it all that well because it's kind of like it's a mesh. So it's a whole bunch of little triangles, and it skins essentially what your part geometry is. So if you're using software like SpaceClaim, which is my weapon of choice, that does actually let you model off STLs in a very clever way. But things like SolidWorks don't deal with that very well at all. So I think if you want a file that goes everywhere, STL's the goods, but you just have to make sure you crank up the polygon count, which may result in a big file. So if you're doing mechanical parts like, gears, brackets, things that are mechanical, step files or parasolid files are great because they're all curve-based and you can edit them later on. You can chuck it into SolidWorks and model it and change it. Whereas if you got more organic geometry, like the scan of a human face or medical geometry, things like that, then STL is going to be the way to go. You just have to be a little bit wary of the file size, but also don't make the file so small that the polygons are so big that it ends up covered in facets, which is a very common mistake. So, right now the software doesn't generally crash with very big files, so it's not afraid of lots of polygons. I recommend just pumping up the polys and having a good STL if you want it to work anywhere.
Cool, thanks, Losh.
Right.
That's all the questions that have come in. So I think we might close it off there. Appreciate the presentation. You know, for those of you out there that are watching in today, if you want any more information, konicmanalta.com.au/products/3D printers or the 1-800 number. Thank you very much for your time this afternoon. It's been great chatting to you. Have a good afternoon.
Thanks, guys.
Giving shape to ideas. Konica Minolta.